As we begin discussing this important topic, two questions should be asked. Who has had a microbial contamination that was difficult to fight, such as listeria? Who has gone through an inspection or audit? If you've answered yes to either of these questions, then let's go on. Antimicrobial floor coatings were first introduced in the 1990s. EPA-registered antimicrobial agents were simply added to existing epoxy formulas. Fast forward to the early 2000s when silver ion-based materials were developed and also added into the material. Both of these approaches relied on the additive to deliver antimicrobial protection, but none were tested and verified for their long-term efficacy. The problem? The antimicrobial properties within the applied material might be affected by the product in which the additive was mixed. Today, the technology has improved and material manufacturers have antimicrobial formulas that are tested and verified as a finished product. And, knowing that the surface can be damaged, the current technology includes a level of protection when the surface is compromised, cracked, or the concrete otherwise exposed. Growth and colonization occurs where sanitation can't reach. Auditors are looking for cracks, harborage points at the cove base, under equipment, or the space where the wall and floor meet. If you are building or renovating, engineering and design play a critical role ensuring these needs are met. If you ever take a good look at concrete under a microscope, you'll see the voids or air pockets, which are a perfect breeding ground for microbes of all kinds. If you want to achieve a food-safe environment or a pharmaceutical, medical device, or hospital-safe environment, flooring and wall systems need to be carefully designed. Part of the process is determining what the priorities are. Before you start a project, list your environment's needs. Do you use a lot of strong chemicals? Are hot water washdowns performed regularly? These and many more aspects of your operations should be considered. From the time antimicrobial was added to epoxy, antimicrobial floor coatings protected only the top quarter-inch of the concrete surface. Once the surface was compromised, potential for contamination was a high risk. Today, protection starts under the surface with an antimicrobial penetrant that permeates 2 to 4 inches into the concrete, creating a barrier that inhibits the growth of microbes. Even if the floor surface is compromised, the concrete underneath still serves as protection. To better understand its powerful protection, this microscopic view shows how the voids and air pockets are filled with the antimicrobial gel. Pores allow microbes to grow. The antimicrobial penetrant creates a gel that fills the pores and gaps, protecting the floor both from above and below the surface. Tests were conducted on fully cured material until microbial test results were consistent and compliant with standard testing protocol. This is a highly technical application that can only be installed by experienced installers that are trained to comply with the manufacturer's direction. Get in touch with Concare today to begin protecting your concrete floor. You can reach us at 866-CONCARE. Visit our website at concare.com.